let's consider an example. The first thing that happens to a letter when they are received in the post office is that they are sorted by zip code. Originally, humans had to sort these by hand. To do this, they had to read the zip codes on each letter. Today, thanks to machine learning algorithms, a computer can read zip codes and then a robot sorts the letters. In this course, we will learn how to build algorithms that can read a digit. The first step in building an algorithm is to understand what are the outcomes and what are the features. Here are 3 images of written digits. These have already been read by a human and assigned an outcome y. These are considered known and serve as the training data. The images are converted into 28 by 28 images, so we have 784 pixels. And for each pixel, we obtain a grayscale intensity between 0, that's white, and 255, that's black, which we consider to be continuous for now. We can see these values by remaking the figures like this. For each digitized imaged I, we have a categorical outcome yi, which can be one of 10 values, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have 784 features, so we have x1, x2, all the way up to x784. We use boldface for the x's to distinguish the vector of predictors from the individual predictors. When referring to an arbitrary set of features, we drop the index I and use y and bold x. We use uppercase variables because, in general, we think of the predictors as random variables. We use lowercase, for example, we might say uppercase x equals lowercase x to denote observed values. Although, when we code, we stick to lowercase. The machine learning task is to build an algorithm that returns a prediction for any of the possible values of the features. Here, we will learn several approaches to building these algorithms. Although at this point it may seem impossible to achieve this, we will start with a simpler example and build up our knowledge until we can attack more complex ones. To learn the basic concepts, we will start with very simple examples with just one predictor, then we'll move to 2 predictors, and once we learn these, we will attack more real-world machine learning challenges.